Hi, everybody. I'm Kyle Bader. I work out at the CTO's office here at IBM, and been working with Seth for a while. And today I'm here to talk about lake houses and using Ceph to kind of provide lake house, data lake type workflows, and really highlight a new interesting development that's happening in kind of data analytics space, which is this idea of a technical catalog. So there's a number of emerging catalogs like Apache Polaris, Unity catalog, OSS, Gravitino, and we also have our own at IBM through watsonx. And it opens up some interesting capabilities with Ceph. All right, we're going. Here we go this way here, I guess. All right, so if we kind of step back, and I've worked with a lot of different customers and people in the community building Ceph-based data lakes and data lake houses as they've moved towards open data formats. And as I thought about the problem, there are some key challenges that I think have really sort of bubbled up to the surface. And that is, one, that the people that are consuming these data lakes or interacting with these data lake houses, they really want to have database level access semantics. So we have really rich access control capabilities with object storage and with Ceph, where you can set bucket policies and IAM policies, and you can set ACLs and all these things. But most of the data practitioners, they don't want to have to think about any of that. They want to be thinking about things in terms of giving people access to tables, giving people grants to those tables. So you can write to these tables, you can write to these catalogs. They don't want to be thinking about buckets and paths and privilege and ACLs and that sort of thing. So we really want to give them a way to provide that strong governance, but in a way that they expect. But we also don't want to kind of see patterns where people are relying on compute side enforcement. So if you listen to kind of a lot of the I want to say noise, but a lot of the discussions that are being had around data lake houses and object-based lake houses and disaggregation of storage and analytics platforms, they talk about not enforcing access control at the compute side, but instead pushing it down and doing access control where the data is, and that's with the storage. So not giving implicit trust to the engine, pushing it all the way down. But you also want to maintain direct paths. So you don't want to be going through intermediaries or proxies or something on your way to the storage, because these data lakes and these analytics tools are so performance demanding that you want to have basically as immediate access directly to it. So what we're going to talk about here is how to take this technical catalog and move up the value chain in terms of like analytics. And we want to push down the enforcement and have it be granular, and don't just stop at table level access control, because with some of the capabilities in Ceph, we could take it to even the row or record level security, which is kind of like the gold standard of databases. And I want to show people what my thoughts are here. All right, so if any of you have worked with data teams that are accessing data lakes in an analytical environment, you might be familiar with something like this, where they have this idea of kind of like namespace scope secrets, where they create a bucket and there's one team that has one namespace. We'll call them the blue team. And then there's another team that has their own namespace in Kubernetes, and they create a bucket and they're the red team. And then they take their static access control, they take their static access credentials for those buckets, and then they squirrel them away in a Kubernetes secret, and life is good, right? They have their ability to access their bucket that they say this application owns this data, and that's great. The problem is that sorts of break down when you have kind of the modern approaches, or let me say this. Is anyone here familiar with what the medallion architecture is for data lakes? No. Okay, so the medallion architecture, think of it like you have a podium at the Olympics, and you have somebody with bronze, somebody with silver, somebody with gold, right? And the idea is that your data will progress through these different levels of maturity till it gets to gold. So if you're just kind of ingesting raw data, you will put it into like the raw zone or a bronze zone, and then you can progress and then refine the data. Maybe you're going to be doing some enrichment, or maybe you're going to be doing some filtering, and then transition it to the silver zone. And then finally, the gold zone is where you have like the tidiest data that usually there's a SLO associated with it about the quality of the data and the availability of it that then can be used for data products, right? So think of the BI dashboards where people are doing analytic reports. Those are often going to be against the gold data sources. So the whole idea, or this whole notion of I have an application, this application owns the data, breaks down when you have to have multiple applications that are progressing data to different parts of this life cycle that are in different buckets. So in a Kubernetes context, if you have, say, the blue group and the red group, but the blue represents the raw data and red represents the staging or the silver data, part of that is going to be transitioning the data from one into the other. So you're going to have to read the data from the blue or the raw. You're going to have to either do some sort of enrichment or filtering or processing of it, and then you're going to store it in the red. But if you have this, if you have a namespace that has access to the blue data, and you have another namespace that has access to the red data, to maintain that separation, you don't want to put the secrets to both into both namespaces, because now there's no isolation. So you kind of end up with the situation where you go, okay, am I going to create another namespace, and I'm going to put both static credentials in that namespace so that the application can read for one and write to the other. And while this is a fairly simplistic example here where it's only, two, think of an organization, a multinational organization that has a whole host of different data sets, and they need to do different sorts of, I'm going to take from this data set, I'm going to take from this other data set, I'm going to combine them together with some joins, I'm going to write them to this other place. And this quickly gets to be a mess in a hurry with the credentials management. So kind of the next evolution is, okay, we're not going to do that anymore because that's a Kubernetes secrets nightmare. And I mean, even if you're not using Kubernetes, right? Like say you're using a Yarn cluster or something, you still have all of these different access keys, and like in your S3A configuration, you have to do a bunch of different per bucket configurations with different secrets. It's really not very scalable. So kind of the next place people go is they go, aha, what I'm going to do is I'm going to take a compute engine like Presto or Trino or something like that that provides a SQL interface. And I'm going to use kind of the engine level access control, and I'm going to have this query engine kind of act as a policy enforcement point. So then in my Presto configuration, I can say that, Tom is able to access this data set, and Sally is able to access these data sets, and you can even go column level or table level or any of that. And when the query gets submitted, if they don't have permissions to do it, it'll just fail. Now this is mostly okay, but you still have to implicitly trust the compute engine. And so this compute engine has access. I've illustrated it as purple here because it has access to the red and the blue data. So it has direct raw access. So if, the administrators of that would be able to go directly to the storage and read any of the blue or red data or manipulate that data. And so that's not really ideal. But for the most part, if we can have this red principal over here, and we can ensure that they're only able to get red data because of the policy enforcement and the engine level. The problem is that when we're talking about data engineering, not just kind of data science activities or BI activities, they often don't just use SQL. A lot of them use domain-specific languages. So they'll use like data frame libraries in order to do the processing. So when they're extracting data and when they're refining, when they're doing the refinements or they're doing the enrichments or they're doing joins and those sorts of things, they're using it with these data frame libraries. And that means they effectively are running arbitrary code, right? So that they have a PySpark application that's able to directly go to the storage. And so while even if maybe they load a library that would say, like, if they tried to use Spark SQL commands, it would say, oh, you can't do that because they've loaded the policy library. They could still just open directly with the storage the data and read it. And then they could, use schema detection or something on it, and then they would have that direct access to the data. So that's where this breaks down, is usually the data engineers, they want the flexibility of using DSLs in order to do the data manipulation and don't want to rely on just raw SQL for doing ETLs and data enrichments and these sorts of things. So they go, aha, I have another idea. What if in between the storage system and the engine, I'm going to write a proxy. And in that proxy, I'm going to only allow people to do things. And this is what I was getting at with the direct path, right? So this is a pattern that I've seen people implement before, where they go, okay, I'm going to enforce the kind of the column level security stuff. And if they're using SQL, then I'm going to enforce it at the engine. And that's going to be good. But if they're going to run PySpark applications and they're going to use a DSL to manipulate the storage, I'm going to just add this proxy in between Ceph and the engine, and that proxy is going to like look at what they're accessing and see what the principal is, and then either allow it or deny it. But the problem is that a lot of these big data applications, they're pushing big gigabytes and gigabytes of data. They're accessing many files, and so now forcing all of this through some sort of proxy, it's going to impact your query time, right? So even if you have a scale out proxy and you have enough of them such that it's not limiting your global bandwidth, or it's not limiting your aperture in terms of bandwidth. So think of it as like, I don't know, if you have a glass of water and you put a straw in it, right? If the proxy is not able to scale, then you're limited. It's not going to be as fast as if you just pour the glass out. They could put a bunch of straws in there, but it's still you're still adding latency, and you're still adding the resources that are necessary to run that proxy layer. And so it's not the most efficient architecture. So what do we do? Well, this is where the technical catalog comes in. And so I started off, I actually got really excited at first by this project called Apache Polaris. And so sometime last year, in the summer of last year, there was a company called Tabular that had been following. It was really interesting. It was a company started by Ryan Blue, who was one of the guys that started the Iceberg project while he was at Netflix. And they were doing some of this interesting stuff with catalogs. And that company got bought by Databricks, and there was like a bidding war between Snowflake and Databricks. And Databricks won, and they bought it. It was like $2 or $3 billion, so it was a pretty big deal. And Snowflake, in response to that, they open sourced a catalog they created this new open source project under the Linux Foundation called Apache Polaris. So that's great for us, right? Because we get access to this. And then in response, Databricks started to open source their catalog that they had maintained privately for their software as a service type approach called Unity. So now there were two options. There was the Polaris catalog and there's the Unity catalog OSS. There's a third one that I've been found out about called Gravitino, but in any event, I wanted to start playing with these because they offer a really interesting capability, and that's this notion of credential vending. Instead of introducing these proxy layers or doing policy enforcement points, what if the engine, when it wanted to access something, it needs to consult a catalog to get information like metadata and schema about the system. If you have policy, and if you have worked with, say, Hive in the past, right, you're probably familiar with the idea of like the Hive metastore. So this is kind of like a evolutionary successor of the Hive metastore, in that it has the schema, but it also contains the policy, and they've developed the ability to do dynamic policy. That's kind of neat. The covers. So Ceph has some really rich capabilities around S3, around IAM and STS capabilities, where instead of just signing requests for S3 with a static set of credentials, you can instead get a temporary credential. So you can assume a role either with web identity or using your static credentials, and then that role will kind of have its own policy on it. If we look in the upper right-hand corner, you see the big circle with a couple different colored circles in it. You can think of the outside circle of being the policy that is on the role. So the idea is we can create a role for the catalog itself, and it has a broad policy. But then when an engine connects to the catalog, it can say, I want to interact with this table. And goes, okay, you want to talk to the green table. So then it constructs, so the catalog itself has a credential, or it has like a JSON web token, and it's the one that makes the assume role call. And in that assume role call, it creates an inline, it dynamically constructs an inline session policy for that role, or for that STS session, that is constrained to just the paths and prefixes that correspond with the table, because it has all that metadata about these tables mapped to these buckets and these prefixes within those buckets. So it can narrowly scope the access on that token, and then it can return it to the engine, and then the engine uses that to sign the requests. And so in that way, you can say, when somebody wants to run a job, it doesn't matter if they're running it with SQL or if they're running it using a domain-specific language like Spark data frames. They say, I want to interact with this table. And then based on the principle, you can set up kind of this information and say, this person can access this and this person can access that. They can give a narrowly scoped credential, and then they sign the requests. They go directly down to storage. The access control is enforced at the storage level, so you don't need any of these proxies. You don't have to worry about policy enforcement points or loading special libraries into the engine that maybe they don't load because they're just running it in a Jupyter notebook or something. So this is really kind of the current best-in-class approach to doing access control for a data lake. And this can take you all the way down to the table level of granularity. So how rich is the ability to do access control? Well, in Polaris, you have this notion of tables and then namespaces. The namespaces can be nested, and then there are some number of namespaces that ultimately route up to a logical catalog. So you can create multiple logical catalogs with like a single instantiation of Polaris or Unity catalog or whatever. And you can think of namespaces as being kind of like a schema in like a relational database. And the ability to nest them is kind of interesting too. So you could think of, if you look on the far right side where we have this namespace 1A and namespace 1B, maybe you have namespace 1A is, say, the US data, and then namespace 1B is, say, the Europe data. You could then construct a policy that makes it so that only engines that are running in the US are able to access the US data, and only engines that are running in Europe are able to access the Europe data. And this can be enforced all the way down at the storage level. And so if we go back to the whole medallion architecture type thing, this is an example of kind of a policy control framework that you might implement in a catalog like Polaris, where you have Alice over here. And Alice, you can think of her as being the catalog administrator. So she doesn't have direct access to the data, but she's setting policies about the association between principals, principal roles, catalog roles, and the catalogs. We have Bob here. Bob is the data engineer, and he's the one that's responsible for progressing data through this, across the podium, right? So he's able to read data out of the raw zone. He's able to perform manipulations, temporarily put data into the silver zone on the way to developing the data products that end up in the gold zone. Then we have Mark here. Mark is the data scientist, and he just has read access to the gold zone data. And this is just a simplistic example where they're accessing everything in the catalog, but you could break this down to table granularity if you wanted to. So this way, Mark just has read access, and this is all can be enforced all the way down at the storage system. You don't have to rely on the engine to do this sort of access control. So the other thing that's really interesting about once you lift up into tables is it unlocks the ability to do background update services. So you could do things like table compactions. So if you're you could, like if you have Ceph and you're providing the object storage and you started to provide the catalog, you could go beyond that and you could provide other additional services. So you could do things like table compactions, where you aggregate the smaller files that correspond with the table and then put them into fewer larger ones so that the analytic queries can run faster. You're able to do this because the catalog has the pointer to the current table snapshot. And so if you were to optimize the table, the data that corresponds with the table, you can create a new table snapshot and then you can move the pointer to the new one because you're managing the catalog. You could merge you could take the delete files. So I don't know if you're familiar with Iceberg, but with Iceberg, when you are doing an upsert or insert into a table, it'll create these little merge files. And then when there's an analytical query, it looks at the kind of the full data files, the Parquet files, and then these more files or merge on read files. And as you accumulate these more files, it degrades query performance. And so one of the things you can do is you can, as a part of a compaction process, you can kind of garbage collect those. You can think of it similar to like a RocksDB LSM tree, right? It's very similar. But you can do other things where you cluster tables by Z order, or you generate vector indexes, or there's a whole bunch of activities that come from being able to do update services in the background because you have that context that points to the current snapshot version of the table. And I wanted to illustrate that it's not just, this isn't something that would just apply to Apache Iceberg. It can apply to other things. So in the Unity catalog, they have this idea of volumes. Volumes is another type of entity you can register that is really associated with unstructured data. And one of the use cases that people use these volume entities for is to point to a LanceDB table. LanceDB, if any of you are not familiar, is a relatively new format for storing vector tables. And so it stores the actual data inside the table, and then you can generate vector indexes so that you can then do vector search against the data. So if if it's a bunch of imagery, you could extract embeddings that say, these particular data assets have cats in them. And then you could search for all the pictures that have cats or something. I don't know, you could do it for whatever sort of embedding that you wish to extract. And you can add additional embeddings as additional columns. And it's designed to do this in an efficient way. But the same sort of governance can apply beyond just the tabular data, but can also apply to the semi-structured or unstructured data. And so you can do that table level access control to the volume entities the same way, where it's mediated by the catalog. So they get a scoped access control credential that limits their ability to access the data. So I wanted to talk a little bit to preview how we could take this further than table level. And if if you're not familiar, one thing that we have done, I think there's been a presentation at maybe one of the CEF days in Asia, but we developed an Aeroflight prototype for the Rados Gateway. And Aeroflight, you can think of it as being or parallel NFS, but for tabular data. So instead of kind of doing like a one-to-one client to server connection, like you might do with ODBC or JDBC to a single database instance, you can think of it as being parallel. And if we're doing this processing down at the storage layer, where we're processing and returning records, and we're not doing whole object reads, then we can get to the point where we get policy information from the catalog, and then we can enforce row or column level security all the way down to the storage level. So if we don't, we could disallow people to do a whole object get, but we could allow them to do a predicate or projection pushdown against the tabular data that's stored in the storage system, and we can return a record set if they have permissions to access maybe one column out of the object, but not all of the columns. And so we can, if we have a more fine-grained API, or we can give record level, we can return records instead of just binary blobs, then we can take this to the next logical level. And that's what I have. So if anyone has any questions, we have some time. Yes. Mm-hmm. Yep.
And sort of understand which rows and columns were adhered to the policy and allow it not on the defined plan that comes out of the policy.
Right.
Right.
Right. So we first thought of the ability to do this, but we never really implemented it, was when we first started to add the capability to do S3 select, because it occurred to us that as we added the ability to basically do predicate and projection push down in the storage, so that they say this object, here's a SQL query, I want you to process the CSV or Parquet data that's in that object and then return the result. We said, well, we could disallow somebody to do a get object, but we could allow them to say, run get select content on a particular object, but we needed some sort of way of expressing, like we needed a policy grammar to express that, they could access that. And there wasn't anything like grants style or privileges style grammar, policy grammar in like IAM or S or like bucket policy or something that we could rely on. So we would have to like invent our own. And we didn't think that that was really good, because then you couldn't use like standard SDKs in order to access it and stuff like that. So we kind of said, well, if Amazon does this, and we'll quickly uptake it, but it never really happened. But what did happen is there is a policy grammar that's being kind of formalized in these catalogs. So when we evaluate our policy, right now we evaluate the intersection of bucket policy and the IAM policy. We can additionally add an intersection where we're also evaluating the catalog policy. And if we have a record level interface, so if we continue to develop the flight support down in the RGW, then we can, then we have the record interface, and then we can enforce it down there. So that's kind of how it would all come together. Yeah. Well, so everything about the catalogs works today, right? So it's just a really good example it's a really good way to leverage the IAM and STS capabilities that are already present in Ceph. So only the last part, whereas like if we want to go into column and row level security, we have to continue to do work like in the RGW to develop the flight server and that sort of thing. Yes, sir. Mm-hmm.
There is already uploading and Arrow for Ceph.
Right. Yeah.
So,
This is all with Arrow. Yeah.
so I see. So this catalog right now is only if you have an S3 interface, right? But can you imagine extending like the metadata process?
So you can, so like, for example, I don't know that you can do it in Polaris, but I know in Unity catalog, you can, like, when you register a catalog, you give a location, and that location can be like S3:// or it could be a file system. I think the challenge is that with file systems, you're usually limited to discretionary access control semantics. And so in some cases, like when you have the nested namespaces, that might be challenging because one of the things with the nested namespaces is that you can modify some of them, and the access, like when it creates the scoped access control convention, it's doing conditions on tags that get put on the objects. And so, it's not always just neatly to like prefixes, which you would need if you were to do it like a discretionary access control type thing. I don't know. I think it's interesting. There are some challenges with, with file systems though, because you're kind of limited to the POSIX semantics. Thank you.